some of the laws that relate interest and discount. In particular, we'll look at laws that relate the rate of interest, the rate of discount, and the law that relates the force of interest to the force of a discount. We'll then finish up with a simple example and then have a quick overview. Now, in what follows, we have that I is the interest rate. If y is the accumulated value and x is the initial value, then I is the interest rate. Yeah, so that means that I is equal to y minus x. If you're a bit unclear about this, you can check out the previous video. I think it was the very first video we did where we looked at that. Analogously, we have that d is the discount rate for y and x. So that means that d is basically given by y minus x over y. Okay, now our first law is that the interest factor 1 plus I multiplied by the discount factor 1 minus d is equal to 1. Okay, we'll start off with 1 plus I times 1 minus d. Now, remembering our values, our properties of the interest rate, the discount rate, we can rewrite these expressions as 1 plus y minus x over x times 1 plus negative y minus x over y. Now the rest of it is just arithmetic, or basic algebra if you like. A very useful formula is that 1 plus a over b is equal to a plus b over b. I recommend you remember that one, because this kind of expression tends to come up again and again and again, and turns out quite useful to memorize that as a shorthand. But applying it to our current problem, we have that y minus x plus x over x times negative y minus x plus y over y. And well, then it's just simplifying. The left hand side simplifies to y over x. The right hand side simplifies to x over y. And well, by just cancelling, you can see that that's equivalent to 1. Now this law, while that's the nicest way to remember the law, it does tend to pop up in some following forms. Namely that often you'll have the interest factor, 1 plus I, and you'll want to get the discount factor, or your discount factor. And then, or rather, you have probably this way, you'll have the discount factor, and you want the interest factor. And you can see that all you need to do is take the reciprocal of the the discount factor to get the interest factor. And analogously, to get the discount factor, you just take the reciprocal of the interest factor. Our next law is that I over d is equal to 1 plus I, and d over I is equal to 1 minus d. The key to remembering these is just to remember that you have one rate over the other rate, and whichever rate is on top, that's the corresponding discount factor, the corresponding factor that's on the right hand side. So here we have I on top, therefore it's 1 plus I, the interest factor. Here we have d on top, therefore it's the discount factor minus d. Alright, let's go about proving these. We start off with I over d is 1 plus I by shunting the d to the right hand side. We have that I is equal to 1 plus I times d. Now, how are we going to proceed from here? Well, the only thing we know is that 1 plus, at the moment, is that 1 plus I times 1 minus d is equal to 1. So this, looking at the right hand side, it kind of looks like 1 plus I times 1 minus d, except we don't have a 1 minus here. So let's see if we can change this right hand side so it looks like our formula and see where that takes us. So do we want to introduce 1 minus d so that we can use this formula? And the way to do it, of course, is by noting that 1 minus d is equal to d. You can think of 1 minus as a function which is its own inverse. So when you apply the function 1 minus and you apply it again, it's the same as the identity function. Okay, now we've almost got 1 plus I times 1 minus d. What we need to do then is we just multiply through. and we get that I equals 1 plus I minus 1 plus I times 1 minus d. Great. We know what to do with this because that's equal to 1, and so we have that I equals 1 plus I minus 1. Now we're practically done. If we shunt the 1 to the left hand side, then it's easy to see that the left hand side and the right hand side are equal, and so that means that this is a theorem. Okay. Now, to prove this one, this is actually slightly easier. We'll start again by basically taking the reciprocal of both sides, because we know how to do I over d. If this was I over d equals 1 plus I, would be done, but it's not. So let's try and turn it into I over d equals 1 plus I and see where that takes us. So first we take the reciprocal. Okay, we've got I over d equals 1 over 1 minus d, and okay, we got I over d over that side, but we don't have 1 plus I on this side. However, remember, 1 plus I times 1 minus d equals 1. So therefore, this is equal to 1 plus I. Remember, if you remember the alternative forms for this formula, we had the 1 plus I equals 1 minus d, 1 over 1 minus d. So we can apply that. And now, well, we just proved this, so we know this is true. Therefore, this is true. And we're done. Lastly, we have that the force of interest is equal to the force of discount. Now, we'll start off with this expression. Now, by the definitions of the I force and D force, we have ln of 1 plus I is equal to negative ln of 1 minus D. Now, if we shunt this to the left-hand side, we get ln of 1 plus I plus ln of 1 minus D is equal to 0. Now, we have 1 plus I and we have 1 minus D. Is there a way that we can arrive at our, our favorite formula, 1 plus I times 1 minus D equals 1? There is, thanks to the property of the natural logarithm. Yes, ln of x plus ln of y is equal to ln of x times y. So if we apply that here, we end up with ln of 1 plus I times 1 minus d equals 0. And of course, we know what to do with that by now. So we have that ln of 1 is equal to 0, and that is in fact a true property of the natural logarithm. So we're done. Okay, let's do a little example. If the interest rate which can be earned on investment is 10%, what is the discount rate? So here effectively we're given I and we're asked to calculate D. Okay, so this is a formula that relates I and D. We can't use the other one because, well, it's not that we couldn't use it, but it's just that D is what we don't want to know. In this formula, I appears twice and D only appears once. Now, since D is what we want to calculate, it makes sense that we only want one D and in the expression, because that makes it easier to sort of get D on its own on one side, and then on one side the equality, and then whatever on the right hand side will be what D is equal to. If we use the other one, D over I is equal to 1 minus D, well then we'd have D in two places. We could still manipulate it, but it wouldn't be as easy. So now let's just get D on its own, as it were, by shunting I to the right hand side. And so we have D equals I over 1 plus I. And now we have I, it's 0.1. So we substitute in there, D equals 0.1 over 1.1. And then with our calculator, we see that's equal to 0.0909. Well, roughly. Actually, it's 0.909 is going forever. But we can actually see, I think this is in fact 1 over 11. Yeah. So D is just under, 10%. So it's close to the interest rate, but it's not the same. All right. So what have we learned? Well, if I and D are interest rate and discount rates for a given situation, then we have 1 plus I times 1 minus D is equal to 1. The interest factor multiplied by the discount factor is equal to 1. And that I over D is equal to 1 plus I. Remember and D over I is equal to 1 minus D. Remember the way of memorizing it. Whichever one's on the top, that's the interest factor that's the factor that'll be on the right hand side. I is on the top here, so it's 1 plus I. D is on the top here, so it's 1 minus D. And finally, we've seen that the force of interest is equal to the force of discount. Yeah? But of course, remember these I and D are related by these two formulas. So basically, we're looking at the same, if you like, transaction. Because we said that X is the initial balance and Y is the accumulated value. Okay, so provided this is the case, then these are all true. Okay, well, that's it. Thanks for your time, and until we meet again, goodbye and God bless.